I think that should be a good level for the music. Just making sure things are up and running. Come on. There we go. I'm like 99% sure the YouTube stream is running. It's just being annoying. And not actually showing it to me. And then YouTube's kind of weird with... Okay, here we go. Now okay. Let's get into it. So it's going to do some real analysis studying, but I noticed I do have a DM over here on Reddit, so let's go and check that. This problem. Okay, so it's a fun problem, but way too advanced for a pre-calc student, the way that it's phrased. This isn't this person who posted the question, but we can still answer it. An example, we're given that converge to something. Let's make up some things they converge to. For hey Jed. Bridge 2 for our example. I saw you posted something. I don't really use Epic though, so I don't know, dude. I just don't like Epic, so in the first one, let's pretend that f of x converges to 1 and g of x converges to 3. This means that they'll approach -2 if we ignore the exponent. But if the exponent let me say they would approach -2 if we ignore the exponent. Hey SPQ. Exponent is there, so we have to consider what exponents would potentially break this. We're not allowed to take the square root of a negative number So we need to exclude k equals 1/2. We can, however, take the cube root of a negative number. So k equals 1/3 is fine. What we'll see is that any even denominator isn't compatible with negative numbers, but any odd denominator is fine with them. Yeah, that's all. There's more that I could say on this first thing with f of x minus g of x to the k, but let's just try and keep it simple because the person said they're really struggling, so. For the second one, let's explain how the sign of k will flip this fraction. For the second one, we have to remember that a negative exponent flips the fraction. So a over b to the -1 equals, well, -2 equals b over a to the 2. Let's, hey Ben, first, we can say that if k is positive, hey, Yanis. Then the f of x over g of x does not flip. So the only time this limit breaks is if we divide by 0. So we need to make sure g of x doesn't approach 0. Similarly, if k is negative, then it does flip to g of x over f of x. And now we need to ensure f of x doesn't approach 0 for the same reason. You know, I put real analysis studying the title, but I might also need to look at some linear algebra today. Remind myself what it means to get the eigenvalues and eigenvectors of a matrix. We'll see how I feel. I just want to write a response to the person who replied to me from a previous math stream. We're working on this question involving what values, I guess k and c, but I mean c isn't really, more focusing on k, when these limits can converge or diverge. And it turns out to be this turned out to be a much harder problem than I thought, but the person is in a pre-calc class, so I'm trying not to give them the hard answer that I'm not even fully aware of. You like linear algebra a lot more, it feels really natural. I've never been a fan of it, to be honest. The calculations are just like so tedious, but I'm trying to help someone out with their linear algebra class, so. I'm glad that you like it because it is really helpful, but it's just not for me. And also, like, I guess my opinion was soured a little bit because I took a linear algebra class as part of my undergrad, and then you know, I went to a community college, which I think is called junior colleges outside of America, to work in a tutoring center. Someone asked if I could help them with their linear algebra, and it was so much harder than anything I ever did. It was like a proof-based linear algebra class, and my linear algebra class never did a single proof. And so it's like, oh god, this linear algebra stuff is like, is weird. So you prefer the proof base and the calculations suck? That's fair. I'm not usually a fan of proofs in general, and I also hate the calculations, so that's why I don't like linear algebra. I can't deny that it is helpful for a variety of things, though. I can definitely see the use of that type of math compared to other types of math that I don't see the use of. The more simple explanation, like I said, this question has a lot more depth if you start considering k equals 0 and such, but just trying to keep things for this context. Okay. Hopefully that helps this person. All right, I did chug through my tea. I'm gonna go put my mug away, and then we're gonna do some studying. You guys will be able to hear me too, so. Oh, you know what? No, I'm not gonna do it. I was wondering if I should eat some of the pie that I made on Thursday on stream, but I shouldn't have like chewing noises. So yeah, I do want to refresh myself on like eigenvectors and eigenvalues. Remember how you find eigenvalues and eigenvectors? I think I remember how you find them, but let's not assume that. An eigenvector does not change direction in a transformation. Yeah, like I said, they're using this image as an example of a linear transformation. So yeah, since you mentioned like having to do like the eigenvector, I figure I should, like, I kind of remember them, but save some time tomorrow and just sort of remind myself what the heck is happening with these. Eigenvectors are annoying to find. Eigenvalues are easy to find. Yes. So if we multiply 1, 4, oh, they're about to show that. So I assume if we multiply 1, 4 into the matrix of there, we should get 1, 4 back out. Oh, times a scalar. That's fair. That scalar is probably the eigenvalue. Okay, yeah. Hey, do mode. How's it going? Do you have another question for me, or are you just chilling? Okay. How do you find these eigen things? Right, this is where you subtract lambda basically across the diagonals. Hey, limit tends to infinity. How's it going? So yeah, you set up this matrix here, find its determinant, you get quadratics for a 2x2 at least. So lambda is -7 or +6. And then when you want to find the actual eigenvalue, or the eigenvectors, you take your first eigenvalue, -7, plug it in here, and solve when it equals to 0, is my recollection. Yes. They explain it in a different way, but that's all that's happening here. Don't really get struggling with double and triple integrals lately. Any advice to ace them? Drawing a picture or just getting really good with like the visualization is the most important part for double and triple integrals, because normally the actual integration is pretty easy, right? It's just setting them up that's the hard part. And the unfortunate thing for getting good at the visualization stuff is just doing a bunch of them. What I can recommend to you, if the site is actually going to work for once, it's okay. It's what we're going to have the time recently. It's kind of annoying. I really like this site in general for everything calculus, and they have a section on multiple integrals. And so I'll link you to the double integral page, but you know, if you scroll around through the like table of contents or keep going through the sections, and they go over triple integrals as well. And for those on Twitch, I'm talking to people who are in the YouTube chat right now, if you're confused. Yeah, so if you want really good practice problems and really good explanations, I highly recommend this site. These notes will go over example problems and have everything worked out. If you want practice problems for yourself, there's the practice problems tab up there and the assignment problems. I think they're super fun, but they're definitely not easy. Double and triple integrals. Yeah, I hope that helps you out at least a little bit, though. These matrices do transformation in space, which is a lot in computer graphics. In that case, the eigenvector is the value that doesn't change direction. The eigenvalue is the scale of the stretch, that's right. Eigen is a German word meaning own or typical. Oh, interesting. This we call it a characteristic vector. The problem limit tends to infinity. Okay, that's an interesting... I don't know, that's the same type of problem. So now I'm talking about rotations, which I haven't thought about, like the eigenvalues and vectors of a rotation matrix. This is an eagle song, but a cover of it? If I remember right? Taking it easy? I think it's Eagles. I don't know. Anyway, it's not important. Hey, Viv. How's it going? Any plans for St. Patty's? Nah, not really. Stay inside and don't do anything. How about you? Hash it out with the college kids? Oh, okay. I like it, Viv. Gonna go like, oh, not you, but me. Okay, I was. Yeah, I'm gonna go crash like the nearby college campus or something. I would say you're being like the cool dad, or I don't know. I guess it depends on the cool or lame, depending on your energy, I guess. But no, I'm not much of a party animal, so. Oh yeah, you get complex eigenvalues, and that's a whole separate thing. I don't know how to show you that on a graph. Huh? I like the honesty. Hey there, Polynomial Ring. How's it going? Went to the parade today. Oh, cool. I guess St. Patrick's Day is technically tomorrow, right? But I guess people are celebrating it today. So right now, so I meant to go study real analysis, which I have open here, and I'm going to do soon. But I realized that I need to refresh myself on something on eigenvalues and eigenvectors in linear algebra. So I'm just kind of like reviewing this page and just remembering how these things work, so I can help someone out with them tomorrow. So, a friend is doing them in his class, and I'm just trying to help him out with them. So I'm trying to remember just how these things work. Okay. Really, for 30 degrees, you get a complex, or like the angle between, I guess like those two is 45 degrees, right? No, that's not really like that important. I think it's gonna be like pretty like computational, not that interpretive, but okay. I feel decent enough about eigenvalues and eigenvectors. So let's what I really wanted to do is practice epsilon delta limits, because Zach's real analysis class is over, but there's still some things that I feel a little bit like I need to reinforce, and epsilon delta limits are probably the top one. It's like I have done them, but I feel like I need to do a bunch of them before I feel really comfortable with those. Oh shoot, I didn't get water before I started the stream. Let me just drink this a bit. All right, let me go fill this baby back up. Oh, try to take my headphones off, right? Could be smart. Honestly, Jed, I was just thinking that I kind of want to grab some pie. I'm just going to mute myself while I chew, I guess, because I'm kind of craving some pie. So give me 1 minute. So yeah, I made this pie on stream on Thursday. It didn't come out perfect. It's my first pie ever, but it came out pretty good by my standards, so. Is it bussin'? Dude, it's so bussin', Polynomial Ring. Or you somewhere having an epsilon delta where the end it was like now that delta equals min d1, d2, d3, d4. Very fun proof indeed. Oh god, where you get 4 different mins to consider? Is that like a multivariable? Like, I can't imagine you'd have something that complicated. Maybe you have like a quartic or something, I don't know. Being epsilon and delta today, hopefully Linux fit physics. And hey, Stooky. Hey, Ariane Yeong. I'm probably saying that terribly, but welcome in. How's it going? Except, why not? I'm gonna mute my mic as I take a bite, because I don't want you guys have to listen to me chewing. Okay. You need 4 different inequalities to hold, so to ensure they all hold, you need delta to be less than... Oh! Interesting. Alright, quantifying closeness. Before stating the formal definition, we must introduce a few preliminary ideas. Between 2 points A and B on their lines given by the absolute value of A minus B. Sure. The statement f of x minus L less than epsilon may be interpreted as the difference between f of x and L is less than epsilon, right? Statement 0 is less than x minus A is less than delta. You can interpret as x is not equal to A, and this is between x and A is less than delta. Yep. Oh yeah. I feel like I remember seeing you in Stooky's stream. Which, if anyone's new and is interested in math streamers in general, check them all out. There's a whole list there. Established Discord math community. Oh yeah, so I have a Discord for this channel, but the one that kind of we're all on is a bit more of the communal Discord is Pen Centers, which we should have a Discord bot command like Pen Center -D, I think. That's kind of the more communal Discord that like we're all on as well, rather than like my personal Discord. Awesome, polynomial ring. Let f map C onto C be continuous, or D to C be continuous, then g of x equals max 0 of f of x is continuous. Oh, that's a weird function. So whenever the f of x would go negative, g of x just stays on the x-axis. It's kind of a funny way to define a function. Yeah, so it's unlikely to be differentiable at those like transition points, I guess. But still certainly continuous. So yeah, that's fair. It's a weird function like that. You could definitely get a bunch of different situations to account for. Consequences for absolute value. Yeah, you can just break it out based on the sign. They also add L to each side, which I wish they explained that, but I'm okay with that at least. You can also add a to each side. Fx we define for all x not equal to a. Really? Why would they specifically include that stipulation there? It's kind of interesting. Like, I know you don't need it to be defined there, but why do you specifically say it can't be defined there? Or maybe it's just not, maybe it's, this isn't excluding if x is defined at a, maybe. It's saying, okay. Just a tricky wording thing, maybe. Let L be a real number, then limit fx as approach to if x equals L if for every epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than x minus a is less than delta, then x minus L is less than epsilon. So this is just our good old epsilon delta definition of a limit. What I want to practice is actually applying it to problems. So maybe before I look at the solution, I should try this simple limit on my own. We had to use epsilon delta because otherwise you could express max xy with absolute values, which are continuous. Really, there's an equivalent, like, max function, like, you could make a max function using absolute values that isn't just writing out the word max. I didn't think that that'd be possible, but fair enough. Okay, so let's go over to the board. And let's try this. Let's try doing an epsilon delta proof just for a line. And see if I can remember how the heck even that much works. Okay, so we're doing the limit as x approaches, was it 1? Yeah. Of 2x plus 1 equals 3. So we're just given what the limit actually is here, and we need to prove that. So our epsilon delta definition of a limit is for all epsilon greater than 0, there exists a delta greater than 0 such that, I don't need to write if x minus 1 is less than delta, then f of x, which is 2x plus 1, minus 3, our proposed limit, is less than epsilon. And so we need to figure out a choice of delta for any given epsilon. This is a weird cover. This is so against like how the song normally is that it's like weird. Oh, that's the max. Wow. Wait, okay. I need to try some example values there, because that's crazy to me that that works. Like that? So wait, if we gave it the max of 1 and 2, we get 3 minus absolute value of 3. Isn't that 0? Oh, x minus y. So then, 1. Well, then we get 1, and that's not the max, that's the min. Plus xy? Oh, okay. Wait, that's not right. Oh, yeah, okay, no, that works. Because then we get 1/2 times 4, which is 2. Wow. And principal bundle, welcome in. RBA, hey. Can you explain by solving for max xy and min xy for max xy equals x minus y? Both of those equations are quote unquote obvious. I appreciate the quotes on that obvious, because huh. That's interesting, principal bundle. Trivial, here you go, Jen. Okay. That's interesting that I didn't know that formula like that actually even existed, so it's interesting to know that's a thing. Okay, so I think how we normally start an epsilon double proof like this is doing kind of like the scratch work or exploration phase where we work with this. And I think I don't know, let's just start working with this and seeing what happens. Maybe it'll make more sense to me as or maybe I'll, like, I don't remember if we need to get to x minus 1 or just x. I want to say x minus 1. So 2x minus 2 is less than epsilon. We could factor a 2 out. And okay, well, that's actually a little bit obvious now, isn't it? So this would imply that our choice of delta is epsilon over 2. Yeah, we don't have to do any like fancy min or anything like that, I don't think either. Because we didn't make any kind of like a arbitrary bounds or anything like that. So I guess, but this is just like the scratch work, I guess. The actual proof is we magically say that delta is epsilon over 2, and we have to show the reverse direction. So from this statement, we say we take delta equal to epsilon over 2. Then so we say x minus 1 is less than epsilon over 2. Then we multiply each side by 2. It's less than epsilon, and then the 2 can come inside the absolute value because 2 is equal to the absolute value of 2. So you get 2x minus 2 is less than epsilon. And then you can say that negative 2 is the same as plus 1 minus 3. Okay. And that would be our proof. Okay. So the line is probably one of the simplest cases, but I guess we can do that simple thing. And RBA, if you have a question, please let her rip. Still improving Weierstrass approximation theorem for polynomials hasn't written at all. The exercise for the reader. Okay. Oh wait, that was polynomials, so the exercise for the reader part, but fair enough. Weekend Gamer, hey, you're able to sneak stats 101 in as your program math requirement at college for your degree. You hate math, but you like Don checking in. Hey, welcome in. You don't need to like math to be here. To be fair, if you don't like math, it might not be the stream for you either, but if you like me, then I appreciate you. But yeah, anyone is welcome to hang out and ask questions. Should give you a really hard but simple Tessarines problem. It's a little intimidating sounding, I guess. Just for completeness, I'll restate the min and max functions. Oh, okay. Let me make it interesting and explain things wonderfully. Oh well, thank you so much, Weeknight Gamer. Exactly what I'm here to like. I just try to do. I feel like half the time I'm not explaining things very clear, but I do try at least. Let me get another bite of pie. Okay. Proving that the Tessarine. Yeah, I don't know. I'm glad that you're so enthusiastic about Tessarine's corrupt converter, but at least if since it's just like a fun thing, I think I'm more interested in doing this real analysis stuff if I'm going to be doing some kind of math for fun. Yeah, this cover isn't bad. Some are a little bit weird. This the same music I was listening to. I was actually I couldn't hear, but the same music I had playing when I was making the pie. And at least Jed was saying that he liked a lot of these songs, so I kind of wanted to re-listen to it. Give you a massive headache in your code? Oh, okay. Fortunate Son, Stella Starlight Trio is people who did the cover at least. I don't recognize the original song. Yeah, I think these are all like covers. There's a zero divisor. Okay. So this is the solution as they worked it out. Oh, okay. I thought they were just gonna do the book thing where they just say choose to delta equals epsilon over 2 and not explain it, but they do explain it. All right, and then now that they figured out what choice of delta to make, wait. Why are they starting with this part? Any algebraists here? I have an algebraic question. Ooh, I'm not aware of someone who's good with algebra that, like, takes questions. That's kind of been like a gap in the like I know, like, there's a lot of math streamers who have, like, at least a little bit of knowledge about algebra, but no one who specifically like likes algebra who streams, as far as I know. Stooky hides, yeah. I'm definitely not going to call anyone out for algebra. You're a bad algebraist? What's the question? PM torsion points of the Brouwer group? Yeah, I have no clue. All of my experience with algebra was trying to cram for the GRE years ago. And not even understanding the basics of it. Algebraists exposed. Addition to width vectors. Oh gosh. This is a... So they're just starting in a vacuum with 2x minus... or 2x plus 1 minus 3. And just doing some algebra or arithmetic with it. But... They say if this, then that. You begin by assuming this and trying to get that. So when we say assuming this, I thought they meant, well, maybe they are, they are taking this and they'll use the assumption later, and they're just saying, hey, let's just think about this. That must be what's happening. Now, are they saying this line is by properties absolute values, which I don't think it is, or... But they don't use an absolute value property. Okay. Like, here they use an absolute value property, but I don't know. Regardless, they take the 2 outside the parentheses. They say, hey, we have a 2 times the value of x minus 1, and we know that absolute value of x minus 1 is less than delta by our assumption, so okay. This is a weird way to phrase it, but I don't see why this wouldn't be valid too. Okay. Problem solving strategy. Let's go this. I'm gonna take a bite of pie as I read it. What's wrong, Ben? You don't like epsilon delta? It's a wild group. To be honest, I don't like epsilon delta either, but I feel like I should know it. Okay, well, you have me curious. If it's a Thumpkin wild group, I guess the Brouwer group, know basically nothing about groups, so... Oh, of course, it's an abelian group whose elements are Morita equivalence classes of central simple algebras over K, with addition given by the tensor product of algebras. Okay, that's not helpful for me. To be honest, I probably just don't have the background to even understand what it's talking about. This is terrible. There's so many words. Oh good, here's some symbols. Much better. No, I have no clue. Algebra is a foreign language to me. Let epsilon be greater than 0 next to a taken value for delta. After we choose this, if you have taken this value, make the following statement filling the blank. Well, okay, I mean, this is the hardest part of the proof, though. I wish you'd break that part out. Everything else kind of follows after that. All right, this is another linear example. I don't feel the urge to go over that. All right, so let's try with the quadratic. So limit of x approaches 2 of x squared is equal to 4. This is where it's going to get a little trickier. So you got to do some bounding trickery. Oh, I caught it. Okay, so under the limit as x goes to 2 of x squared is equal to 4. Okay, so let's write down our epsilon delta definition of a limit. For all epsilon greater than 0, there exists a delta greater than 0, such that x minus 2 is less than delta, implies x squared minus 4 is less than epsilon. Okay, so same thing, let's start out with that statement. You know, this is it's kind of a nice case, like, because this is going to factor and we're going to get an x minus 2. What happens if you factored and you didn't get an x minus 2, but let's do the easier case for now, I guess. So let's start with the we'll do our scratch work here with that one. So x squared minus 4 is less than epsilon. X squared minus 4 factors to x plus 2 times x minus 2. And we observe there's an x minus 2 and an x minus 2, so we want to key in on that. The product of two things in absolute value is the same as the absolute value times the absolute value. So we'd say this is x plus 2 absolute value times x minus 2 absolute value less than epsilon. Divide each side by the absolute value of x plus 2, because we want to isolate x minus 2. But what the heck is, you know, epsilon over the absolute value of x plus 2? That's weird. So this is where we have to do the weird stuff. Yeah, Yanis. So I kind of know the trick, which is we just arbitrarily are going to take x minus 2 as less than 1, and that's going to provide a bound for x plus 2. And that's where we have to do, like, delta's going to be the minimum of 1 or whatever we get for epsilon. So I remember how this absolute value relationship works. So if the absolute value of x minus 2 is less than 1, that means the distance between x and 2 is less than 1. So we have positive 2 here. 1, 2, 1, 2. If we're less than 1, we're between here and here. But if we have the absolute value of x plus 2, it's 0, 1, and negative 2. That means negative 2 is at worst 5 away. If we take the far end of that, well, don't we have to take the far end of this too? So it should be less than 6. Right, rating it was like full inequality just shuts your brain off. Yeah, this is where actually, where do we take that end? I I feel like we should take the worst case scenario, which is like negative 3 up to 5, up to 3, which would mean this is less than 6, right? So would we say epsilon over 6? If we're dividing by a bigger number, isn't this smaller though? So that doesn't really make sense. Like, or we're choosing a delta that's more restricted. So like, would we say, maybe we do want this to be greater than that, because that means our delta is epsilon over 6? This is where I get a little weirded out. We did almost the exact same, we might have done the literal exact same problem. On a prompt. I may need to look at the solution here, because I know I have the vaguely right idea. I'm just not quite connecting every dot here. You're gonna type up, or you're gonna tech up your solution the way it's not readable? Sounds good. Okay, I'm wondering, like, I feel like we should have a square root or a squared somewhere in the answer, and just straight up epsilon over 6 is a little too simple. You say epsilon over 5, really? Should it be that symbol when a quadratic is involved, though? Like, there should be some kind of, like, square root, like the problem has. I don't know why I don't get one, though. Because, like, depending on where you are on the quadratic, the change in vertical height becomes greater or less. If we're doing it geometrically, I don't want the geometric explanation. Decays faster than square root. Really? Well, I guess we only care about it over a certain, for like small epsilon. I guess we could try examples, like if we, epsilon less than 1 then epsilon squared is less than epsilon. Place the epsilon with epsilon squared, maybe eliminate the square root that way. I mean, I guess it wouldn't factor to be a perfect square, but I could see how reasonably you get something that's like reasonably linear, I guess, if you were to make that. So, so maybe it's okay that we have a linear answer here. Let's see what you put, Yanis. Hey, Machni, you want to say how you saw this thing? I don't blame you. Oh, you get a delta squared. Oh! I feel the exact same way, Machni. I just feel like I don't understand it very well, but I feel like I should know it, so... That's an interesting way to do it. So... we know that epsilon x minus 2 is less than delta, so that's how this step happens. And then we say that we want to take this epsilon x plus 2 and make another x minus 2 out of it if we can. So we say that positive 2 is the same as negative 2 plus 4, which gives us an x minus 2. And is that a property of absolute values? You can just bring the 4 outside of the absolute value? Plus, okay, yeah, yeah, with triangle inequality, that's okay. Okay. Okay, so yeah, if that's a less than or equal to, I'm on board with that. And then we have another delta there, so you get delta times delta plus 4 is equal to delta squared plus 4 delta. And then if delta is less than or equal to 1, you can get rid of that squared. Oh, okay. And so if delta is greater than 1, you just, or sorry, if epsilon, well, okay, you need to deal. So, yeah, I mean, this is a neat way of doing it. And you can just say that you never choose a delta that's greater than 1. So you could take the minimum of 1 and epsilon over 5, just to force this equality to always be true. Yeah, that's what I was trying to like figure out the justification for in my head. And I think this thing I had with the absolute values, I feel like it should be 5, and it should match what you did. I guess epsilon over 6 is just it's also fine. Like, it's just like overkill compared to epsilon over 5. Because you're fine if you go smaller, just so you're not fine if you go bigger. But I think I should get clarification on this inequality bounding thing. Okay, so that is a neat solution. Thank you for saying it. Actually, so I always forget to do it. Let me give you a save. Just a little like for fun thing. Let me see. I hope the notes from the realness class are still posted. Okay, let me see if I can go and dig up where we did these absolute value bounding things. As part of the real analysis class. Slim definition of derivative. I need to go further back. Oh, could this be it? No. Getting close though. Okay, I think this one might be it here. So I remember the way that we were doing it in class. Oh no, this isn't it. This actually might be helpful too, though. I'm gonna open this thing up, but it's not the exact thing that I wanted to find. Let me keep looking. This looks like it's it. The one right before this one. Oh, and we do a quadratic case. Okay, good. Yes, I think we do. We might not have completed it if I remember how that class went. Yo, underscore, how's it going? So I want to find this exact question here. I'm going to take a bite of pie, and so I'm going to mute my mic for a second, but yeah. Oh, epsilon number 3 works. Interesting. Yeah, you know, there's a much easier way to do it than the number line way that I was thinking. I don't think that's basically how you did it there. It's an easier way for me to think about. If we have x minus 2 absolute value is less than 1, we can just manipulate it to look like x plus 2. We add 4 to each side. So right? So 3 is less than x plus 2 is less than 4. That doesn't really make sense though, does it? We want it to be centered, don't we? So could we say maybe this isn't right. I don't know. X plus 2 is greater than 3. Oh. We don't care about bounding it from above, we care about bounding it from below. Because we want something that's, if x plus 2 is greater than 3, then if we divide by a number that's smaller, we get a bigger number. That's what I was missing. So I was thinking like we should be able to chain that along. Okay. Okay, thank you for that, because I was like, there should be some kind of way with the absolute value here. Thank you for that underscore. Let me go put my plate away, because I'm a lot of pie. I hope you guys can enjoy this dish ASMR. Okay. Out of pie. Yep, feels bad. Now I don't have to eat on stream and mute and unmute my mic. So yeah, just when we were doing class, we had absolute value x minus 4 is less than 1. We just had this problem in a vacuum. So yeah, this holds for between 3 and 5. And then we call that, I guess our word for part C is right here. There are multiple correct answers that work. Being more precise than others. Yeah, underscore that. That's true. I don't know that we were like specifically taught to do it, but I do like the way that you did it. I like the way that Yanis did it. Okay, so we started with x minus 4 is less than 1. We shifted over by 1, and we found that k should be greater than or equal to 2. In here, we shifted over by 4. Funny enough, we only added 2, though. And the second part was x plus 2 is less than k2. I just want the center to reach all the way over to the endpoint. That's right. And so in my number line interpretation, that's why we would get 5. Okay, there we go. That's a question I really wanted to answer here, but how do I make my number line work? Yo, Pen! Thank you so much. Welcome in, everyone. Mary, hey. Do you understand this thing more than when you joined? Hell yeah, Machni. You have flashbacks of a teacher wanted to solve a question by calculating the exact value of a long integral for 30 minutes. All I wanted to do was bound it from above. Oh gosh, underscore. Yeah. Welcome in, everyone. I'm doing my normal kind of like taking questions from chat thing, but instead of looking around on the internet for like questions to do in the meantime, I decided that I want to study some real analysis because with Zach's class ending, there's still some things that I wanted to like revisit and reinforce. And so I've been going over epsilon delta limits because that's probably the top thing that I want to like have down more. Like that's from like half a year to a year ago. Yeah, like I only ever shown that this epsilon delta limit exists in my calculus classes. We never did anything with it. I never took a real analysis class either. There's more that you want to learn too? Yeah, Mary. So if you want to like work together on anything, like I think having more people is better than fewer. Obi, hey, yeah. I mean, or honestly, if anyone wants to like hop on Discord now and just like work out some of the stuff on a whiteboard, I definitely don't mind either. I've been going through this website and trying to work out some of the example problems they have here. What is this monstrosity? Oh yeah, so they this site does the same limit a geometric way, and I think there's probably more like a more precise way to get your value of delta if you do it this like geometric way, but I don't really want to do it the geometric way because I feel like it's not going to be very generally applicable. Oleg Mangoose, thanks for the follow. That sounds like some weird invader from a Dark Souls game. Shima's awesome. Oh well, thanks so much, Oleg. Yeah, my normal kind of shtick is I on Tuesdays, Thursdays, and Saturdays I will do these math streams where I take questions ideally from chat, but if no one's in chat as a question, I'll look around like on Reddit and stuff like that. Actually, I should make sure the site doesn't have anything new, right? Okay, it doesn't. But for today, I'm kind of doing like just like some studying instead of looking around on the internet. Finding through Penn Center. Oh well, awesome. If you want even more math streamers, there's a whole list of them there. I recommend you just go down the list and hit follow if you're interested in more. in Penn Center. Phew, we learned about Laurent series and tried to get into residue theorem today. Ooh, cool. What is the small e? That's epsilon. Greek letter. And if you ever, it's still kind of a pain, but if you want to like type Greek letters in chat, we do have this like symbols command that has a whole bunch of like math symbols. So epsilon is in that list. Well, there's actually two different versions of the epsilon. The one we're using here is that one though. Hey Maxi, it's okay to put a lower bound of 0 for epsilon, which is weird because epsilon should be strictly greater than 0. Where did they say that? The site does do things a little bit weird, but I don't know how you say that symbol. I know it's like an algebra, like generic operator symbol or something like that, but direct product? Oh, okay. Yeah, I feel like we're pretty integrated. Change the x squared with x to the fifth plus x to the fourth, and you can't find the f value delta, so you gotta change your perspective. Okay. Thanks, Matthew. Oh. Direct sum. Okay, I was wondering why it looked like a plus, but it was a direct product. You're able to calculate crazy real integrals by integrating complex contours. Ooh. So I think I feel satisfied with this quadratic epsilon delta problem. Some nasty viewer given integrals to solve, and you need some strong tools to do it. Oh, okay. I honestly I assumed you were talking about for the complex variables class, but that makes even more sense. You have those complex integrals to solve as well. An infinite direct sum is 0 almost everywhere. Well, an infinite direct product need not be. Really? I honestly I thought that direct sum was like some kind of generic like symbol. Like what it actually means depends on the context. You don't think you want to know what those mean yet? Yeah, I don't blame you. That's the triple line integrals I have Cthulhu. Well, I'm not going to ask you what this symbol is then. Is that the boob of Cthulhu? Boobs? We could try it for this root x equals 3. Actually, what else did we do this day? Did we actually do this number 6 for x squared equals a squared for a generic? I don't think we... no. Number 5 does look kind of interesting too, though. Did we do it? I feel like we did. No, I think I did the x squared equals a squared. Like on my own. Maybe actually, you know what? We should just do this x squared equals a squared one again. I feel like I did it once, but I feel like it'd be a good exercise. Now I did I did it with a equals 2. Now let's do it just for a. Getting tensor every day. All right, so I'll take the work that I have on the board and generalize it for, instead of 2, let's do A. Let me get some water first, though. Okay. All right, so we're gonna try and generalize our proof here. So we want the limit as x approaches a of x squared to be a squared. So x minus a is less than delta, and x squared minus a squared is less than epsilon. Now when we do our scratch work, do x squared minus a squared is less than epsilon. We can still factor the difference of 2 squares, which now this is making me wonder if you should do it for a general polynomial, ax squared plus bx plus c, but that might be a little, I don't know if I want to do that yet. The same thing split up into 2 separate absolute values. And then we have x minus a right here. So let's divide over the x plus a. Then we do the same exact bounding thing here. But that's how I want to do it, at least. So let x minus a be less than 1, then x plus a is less than something. So rather than do the number line way, let me do it maybe this way again. See if it makes sense of this. So we're going to add 2a to each side. So then x plus a is positive, so you could say, ooh. And we only care about this bound, so I'm going to chop off the thing on the right. Like that? And so we want it to be greater than, that's right. Because for this inequality to hold, we want to divide by we want to divide by a smaller number, yes. No, wait, if you divide by a smaller number here, you have a bigger overall number, so we want to bound that again from above, okay. So dividing by a smaller number, 2a minus 1. You're off to enjoy a beer on the patio. Oh, nice, Pen. Yeah, it's warming up. It's really nice out. I think I'm not ready enough for this symbols because oh, that's Machni. Yeah, Pen, please, yeah, enjoy your beer. Thanks so much again for the raid. I think you're not ready enough for the symbols because you're in 2 graded in high school. Oh, I mean, I haven't even encountered all those symbols. Limit of products equals the product of limits. Oh, that's fair, Maxi, yeah. When it comes to general polynomials, you're better off proving 1, that all functions xn are continuous at a point A, than 2, the... Oh. Oh, that's true, yeah. If you have the addition, you just break it up into individual limits. You're right. So yeah, I guess there's not a huge point in doing like ax squared plus bx plus c, because you just split up into, like, in this case, a linear case and a constant case. Okay, fair enough. So in this case, we're saying we're going to take delta equals min of 1 and 2a minus 1. Oops. And hopefully this math works out. So if we now use our choice of delta. Wait, sorry. That's not right. Epsilon over 2a minus 1. I was like, we're not going to get an epsilon when we plug in. There we go. So now if we want to go through and do the actual proof part, we're going to say absolute value x. Oh, who's that? That theta lem oh one. Thank you for the follow. You're my 600th follower. Thank you so much. I'm sorry I can't pronounce your name, but thank you very much for the follow. And when I'm big and famous, you can say that you're my 600th follower. So that's pretty cool. Hope you're doing good. All right, so if we say x minus a is less than delta, we're saying our choice of delta is epsilon over 2a minus 1. So let's see how this works out, I guess. So I assume we want to multiply 2a minus 1 over. Yeah, we're gonna have to do some inequality magic here. 600, let's go. Bro. Thank you, Marion Stuckey. Okay, so what's 2a minus 1 is going to be less than or equal to its absolute value? So this inequality, it goes the wrong way for the situation we have up here. So I don't know if really we can't use that. Oh wait, should we keep it as absolute value 2a? We might want to. Yeah, because a can be negative here. Should we? No. I don't. How do we do that? Sounds like Merriweather from GTA 5, and you just add remark. Oh, I don't know the Merriweather in GTA 5, because I haven't played any GTA game, actually, but as far as I know, yeah, it's Merriweather, remark. So what happened before is we just had, like, that was 6, and 6 is just a positive number. Here, we're not assured that's a positive number. So, because we have to consider negative a's. I feel like the square root wasn't easy, but also illustrates another technique, so I guess it's nice. Oh, you already went ahead and worked out the root x one? Okay. Okay, you know, I'm not sure exactly how we would get there, but what does happen if, so I'm thinking, like, I assume we're going to multiply 2a minus 1 times x minus a. What does that even result in? Because don't we need x? We need to build to x squared minus a squared, so we really need to pull some inequality magic here if we're going to get there. We've got an a squared. Maybe this isn't the key. Maybe, we want something that's less than this that behaves the way that we want it to. What could we name here? Because otherwise we just, our inequality that doesn't work. Oh, the speaking part of this song scared me. Well, okay, what happened over here? Because it's really just doing this in reverse, isn't it? Maybe I should be thinking more about that. Wait, so I made the claim that... Oh... To a minus 1, we already established that absolute value of x plus a is greater than 2a minus 1. And that's just the key to the proof. Does that inequality even go the right way now? Wait, 2a minus 1. Wait, no, we need something that's less than 2a minus 1. I'm getting confused. Why is this so much harder? Murray weather? Oh, okay. Oh wait, am I taking the wrong side of the inequality here? X plus a is less, if I want the other side. Oh yeah, Mary, so I have a webcam right there, and then the big cam is my iPhone. If you want a tip to continue this direction, maybe making a number line showing minus a to a. Geometry ways, yeah. Because I was trying to do it this way specifically because that's how we were doing them in like the real analysis class. It's not like we have to do it that way. It'd probably be a good exercise to try it your way too, Yanis. Oh, it's not a perfect solution, but the only free one that I could find is using vdo.ninja, that website. So that's what I use. It connects over Wi-Fi, which I was hoping for a wired connection, but that website, you go to it on your phone, and it gives you a link you can put into your OBS as a browser source. It's a little bit of a pain because I have to do that every time that I stream, but it is what it is. If you want to, so making that number line you're saying underscore. max value of x in the line. I'm not sure what you're saying with that, Richard. Is your whiteboard in 4K? Oh no, it's just 1080p. Video, I don't know if my phone actually does 4K. It's an iPhone 12, I think. Not Max or anything like that. But Video Ninja definitely only goes to 1080p. And I don't think Twitch does 4K. I don't know though. On YouTube, you probably could. So, okay, let's just make a number line, I guess, but I thought I did that right, because I did it the same way that we did it, like the algebraic way. So, okay, we're arbitrarily saying the absolute value of x minus a is less than 1. So we have that interval there. And then we're concerned about bounding x plus a. And I feel like here we wanted something that's greater than x plus a, but I feel like over there we want something that's less than, well, 2a plus 1 is less than x plus a. Oh wait, am I just reading my inequality backwards? Wait, 2a plus 1 is less than x plus a, is what we said over here. So, no, never mind, dude. Two a minus 1. Yeah, no, never mind. So, if we're concerned about x plus a, that means, I guess we're taking a as positive here. We want to get from negative a, we want to cover basically from the center here all the way to the end there, which is 2a plus 1, that distance. If you're on 4K on Twitch, you might have to be a big player to get that kind of bandwidth. Oh yeah, it might be like a partner thing, Mary, or even like a, like even some kind of special partner deal. You did the square root wrong. Oh no, Yanis. So I think what I said is like this inequality is true. I feel like I'm just maybe using the wrong part of the inequality. It's weird because I should be able to follow these steps backwards when I'm doing the actual proof. But I feel like the inequality is going the wrong way now. For some reason. It's like I said, like if I said this here, why can't I say this like the same thing over here? You have a trick question. Let's assume a is positive. Where's negative a compared to a minus 1? Well, if a is positive, then you do a minus 1 minus negative a is 2a minus 1 away? Like when, if the me of like 10 minutes ago figured out that this inequality is true, why can't the me of now just now do this and not think too hard. Then the problem becomes easy. But I guess, is the me of 10 minutes ago right about that? It should be, because x minus a is greater than 2a minus 1. And if you divide by a smaller number, it's a greater overall value. So I think this is okay. I hope. I guess. Not super confident on that one. I am interested. Okay, let me pull up what Yanis did for that other quadratic and also try it that way and see if things kind of match. So, if I were to do it Yanis's way, we would say, to finish the proof, is delta greater than 0? Oh. Well, we're given delta is greater than 0, isn't it? Oh, ha! You're right. If there's... Do we need the absolute value? Because you're right. If that's a negative value, we're in trouble. So, is that what you were saying about the distance between negative a and a minus 1? To lead towards where the issue is? Ah, okay. So, I mean, I just want to slap absolute values on each of these, but I don't know if that's true. So if a is negative, what happens? If a is negative, this thing like it kind of flips, I guess. Maybe let's just draw it. So we'd want to cover the distance between negative a and a minus 1. So we can take negative a minus 1, which becomes minus 2a plus 1, which is the negative version of that. Does that imply that I can slap an inequality on that and it's still true? Should I try with actual values? That might help me for A. Okay, wait, let me look at what you're saying, underscore. Take the previous example, we had x minus 2 and x plus 2. The question is, why do we set x minus 2 less than 1 and not x minus 2 less than 3, for example? I might see why 1 works and not 3. Oh, I thought you could also put 3 if you wanted. Just 1 is a nicer number? But putting negative 2 and x on the number line, you might see why 1 works, but not 3. I guess let's try that, because I don't see why not. Take x minus 2 is less than 3, and then we're concerned with x plus 2. One, 0, negative 1, negative 2, 3, 4, 5. So B so why can't you just go from negative 2 out to positive 5? I don't see why that doesn't work. You could say that x plus 2 is less than 5. But no, we wanted to find what it's greater than, right? This is weird. That's why I'm trying to review this stuff, because I like the absolute value stuff is just tricky. We want a lower bound on x plus 2. I need to relook at it for, I guess, the case that does work. Oops. Oh wait, no, we were saying x plus 2 is greater than 5, weren't we? Yeah, okay. This can only be true if x plus 2 is greater than 5, because we need to capture the entire thing or be beyond it. But wait, no. That was for the one below here. So why doesn't... This inequality holds for anything that's 5 or more. This inequality, or like, we haven't made it an inequality yet, have we? As long as x plus 2... Why don't we get a similar bound from below? I guess I'm just not following what you're saying. Spin 5. Okay, so yeah, I was I was thinking, like, you know, if you go past -2, then I could see there being an issue. Because now you're going out here. Somewhere over there, who cares? And so when -2 is contained in the interval, I feel like this still works, doesn't it? So you still need to be like from there out to the farthest endpoint. You know, it'd be weird to choose like 5, but I don't see what's wrong with that either, to be honest. So I don't know, I mean, like, I feel like maybe we just, when a is greater than 0, we take this for delta, and when a is less than 0, like, can we just say a greater than 0? Minus 2a plus 1 if it's less than 0? Like, maybe there's a more elegant way to do it, but like, could we say that? X could be equal to -2, and then x plus 2 equals 0. I feel like you'd say that about any other situation, though, underscore. I'm sorry if I'm, like, just not following you. I'm not trying to be, like, argumentative. I'm just, like, trying to understand, I guess. Because, I mean, like, we're not allowed to choose anything in particular for x. We know that x is approaching a. So we don't know x is getting close to +2. I don't know. You could very well be right, underscore. I'm just not The goal was to satisfy x minus 2 is less than epsilon over x plus 2. Yeah, I mean, we basically, we want this. I'm not sure. I think I'm gonna go pee quick. This is, I guess, an interesting problem. Like, I think I didn't give it this much consideration when I did this problem the first time around. So maybe I might have missed some like depth. But yeah, I'm gonna use the bathroom quick. I'll just be back in like 1 minute. Okay. So I think, wow, I already got through almost the entire bottle of water already. Hey, Ipsum. Oh yeah, no, that's a good question. So I've been reviewing epsilon delta limits, and the goal of this question was to prove the limit as x approaches a for any generic a of x squared is equal to a. So we're not trying to find x or find a value for a. We're trying to prove that for any given a, x squared will approach a squared, basically. So we're not worried about the actual value of x or a. Well, we are worried about it, but we don't... we're not solving for x or solving for a explicitly, I guess. sum of the first solution. You want epsilon greater than 0. You can find delta greater than 0 such that for x minus 2 is less than delta, absolute value of x squared minus 4 is less than epsilon. Independently of x. You want to bound x plus 2 from below independently of x. Okay, right. So if we want to bound epsilon over absolute x plus 2 from above, let me just remember why we do want to do that. Okay, yeah, because we want to maintain the inequality with absolute x minus a. Okay. That means we need to bound absolute x plus 2 from below because it's a reciprocal. The def item is not dependent on x. Yes, fair. Since x is supposed to be close to d, you can pose x minus 2 small enough so that it helps with the research above. So I feel like I understand that. I still don't understand why we couldn't have x minus 2 is less than 5. Because what if we had a equals to like 0.5? Our choice of 1 would, or you know, or like 0.25 or 0.1 or whatever. Our arbitrary choice of 1 would still overlap. Or just a equals 0 as well. So that's why, like, on that, you know, kind of, I guess, topic, I don't really understand why you couldn't bound with something other than 1, even though it's weird. But I think with the work, at least I did, like, I think we actually can. We worked it out separately for positive and negative a, but this ends up just being, we could just take the absolute value of 2a minus 1, because this is just the negative version of that. Because if a is negative, this is always positive, and if a is positive, this is always, well, not always positive. Oh gosh. What if a equals 0.1? Oh no. Maybe I just need to see a proof written out of this. Because I thought I had it worked out with the cases, but then I realized that the sign, if a is small, that kind of messes with a lot of things, doesn't it? Potentially. Epsilon delta proof. for a limit as x approaches a of x squared. Or arbitrary set x minus 2 is less than 5, you can't bound x plus 2 from below with an restricted positive. X equals negative 2. Okay, I guess that's fair enough underscore. But I think things still get tricky if we have small values of a. These are all people just doing as x approaches 2, though. Not for a generic a. Hmm. Oh, this is another kind of weird cover. Oh, here's a YouTube video that does it. How does this person do it? So I think this might just I just want to see the answer. Okay. So they're letting x minus a be less than 1 again, and then they do triangle inequality, say absolute value of x minus absolute value of a is less than 1, so absolute value of x is less than the absolute value of a plus 1. Oh, are they going to plug this into the x plus a? Or how's this going to work? The absolute value goes on just the a. That's how you fix small... Okay, and then you don't have to worry about small values of a, do you? Because you're doing plus 1, I guess. So long as this algebraic way is probably better to do it than my number line way. No, actually, I should get 2a plus 1, my number line way. Well, actually, no, I'm bounding it for x plus a from above, though. Wait. Something bigger. How are we going to use this? Isn't the inequality going the wrong way? Because we have that. But 2 absolute value of a plus 1 is greater than absolute value of x plus a. Wait, I'm just doing this backwards? You can use this? No, this inequality goes the wrong way. You're dividing by a bigger number. Oh. I just read the description of this video. Did this person's account get hacked or something? Or okay. The comments are all normal, so I feel like this person got hacked. That just doesn't seem valid. Two A plus 1? Okay, honestly, I don't want to keep that description up on my screen more than I have to. So, I mean... Hmm. So, okay, I'm just gonna try, like, one last thing with this. We can fix this whole issue with the sign of A, like, just by doing 2 absolute value of A plus 1. When I did this up here, shouldn't I have done I shouldn't that have been plus 1? Or wait, no. I was taking the lower bound, that's right. But then if we take the lower bound, like, we potentially have a negative, even with an absolute value. If you take the absolute value of A there, you can still have a negative number if A is small enough. I think we're just going to call it on this one. I'm just going to do a different problem because I feel like I just need to do outside research on this. The max value of x plus 2 with the ball centered at 2 with radius 1. No, Bio, I don't have a question in queue. If you want to ask it. Pick the max value from the ball. Well, I guess centered at 2. Would it be centered at negative 2? X plus 2 with... Okay, let's see what you are linking underscore. Peak drawing quality? Okay. Oh, dude, this is really good. Wow, a giant add-on. Oh, shoot, I'm not even showing the screen. Oh yeah, Richard, we worked that out. We just kind of got a little, like... I need the rest that you get by dividing x to the 2023 minus x to the 2021 minus... or plus 2x squared plus 5x minus 1 by x cubed plus 3. Oh my god. With complex numbers? I'm gonna look at this first, and then I'm gonna, I guess, try doing that division. So, I mean, is this pi? Is pi just a generic... Pi is just a generic... You're using, like, I guess, epsilon. You know, let me just work on bios problem. And it's basically gonna be what underscore said, which you responded so rudely to. It's gonna be the same process, so maybe you shouldn't, like, you know, be an asshole to people who are trying to help you bio. Just gonna give you that tip of the knife. So we have x cubed plus x. X to the 2023 minus, what was it? X to the 2021 plus 2x squared plus 5x minus 1. Okay. And it looks weird, but it's just normal polynomial long division, I think. Well, does 3 go into 2023? $18, 223. Does 3 go into 223? It doesn't. I don't think, like, we don't want a fractional exponent, do we? Or we do we divide it by x and divide it by x squared plus 1? Yeah, I'm already confused how you make the x cubed match the x to the 2023, because you just get a fraction there, don't you? Subtract? Oh wait, I forget my exponent rules. Yeah, you add or subtract, you don't add. Thank you, Stookie. I don't think we need the roots of x cubed plus x, do we, Bio? Just to do this the division? Okay, now evidently I forgot how to do polynomial division. But yeah, no, if we want to make x cubed max x to the 2023, you do x to the 2020, because the exponents they add, not multiply. So you get 2020 plus 3 is x to the 2023 plus x to the 2021? Because there's a difference in two. Okay, I guess that makes sense that we get something that matches. So minus 2x to the 2021 plus I guess just worrying about the 2021 part. We're going to get a remainder for sure. X to the 20, or minus 2x to the 2018. Minus 2x to the 2019. That's where it gets a little weird. So you get 2x squared. I don't know if I should drop that 2x squared down or not. I feel like I shouldn't. I mean, I don't know. It doesn't really matter. Or does it? No, the weird powers here are throwing me off. I'm going to be honest. Oh, you have to fill in the zeros. Oh my god, yeah. You're right. Shoot, I forgot. When you do polynomial language, you have to fill in all the zeros between 2021 and squared. That's why I was getting confused with the powers. Okay. So yeah, no, doing that by hand. Okay, I thought. Sorry, I'm rusty on that. So either there's a pattern in that long division, or we have to do some trick like you're saying. Zero and plus and minus I. Oh, you hope that there's a cancellation. So if you have x to the 2023. Oh shoot, I shouldn't have erased that. Okay, sorry. You're right. We do want to factor this. To the 2021. Plus 2x squared minus 5x. Plus 1. Okay. Oh wait, minus 1. Is that it? Wait, plus 5x. Oh my god. Dude, epsilon delta has my brain fried. Apparently. So x to the 2023 minus x to the 2021 plus 2x squared plus 5x minus 1 over x cubed plus x. Okay. There is no cancellation? So if we factor, let me look at it for myself, I guess. So the x certainly doesn't cancel. Over x plus, oops. It'll be x plus 1 squared, which factors to x plus I times x minus I. And so we have to hope that plus or minus, so like x certainly isn't a factor up here because it's a minus 1 on the end. So we have to hope that I or minus I are factors and see if there's a cancellation, I guess. We still have to figure out what that becomes after you divide out x plus or minus I. So I don't know if this is even gonna like be that convenient. So if you have, let's just try it with x equals I. On top you get I to the 2023. It's like I cubed, right? Because 2024 is divisible by 4. And I cubed is negative I. And that's like just I? No. 2020 is divisible by 4. So that's like I squared maybe? Just minus negative 1? Oh my god, I feel like I'm doing some horrible mistake here. That's definitely not 0. Yeah, I'm sure it's a trick here, because like whenever they have a year in there, it's usually like some kind of like, I mean, well, a lot of bios questions have had the year in them for whatever test he's studying for. So yeah, even if you do it that factor way, you don't get something that's easy to divide still. Like you could break up the fraction into two different, like you could break it up into like a, like along there. I know, is I or minus I a root here? Negative 2 plus 5, I meant no. No? There's no roots there. And I don't think you get a root there. Negative I? Yeah, I don't know. That's a weird question. P be the big polynomial when d, we divide it by, then we know we can write it like this: P equals QD plus R, where Q is something and R is the rest. Plug in the roots of D. We get P of X equals R of X for the roots. And we know the degree of R is less than 3. Oh. So we don't mind that the thing on top doesn't go to 0, or doesn't have those as factors, necessarily. Let me get more music going, then I'll go back to the board. All right, let's see if we can work that out. All right, so actually, so the question about we only need the remainder, and that's why this is a good idea. I need the rest that you get by dividing those two things, and we can interpret the rest as remainder, I guess, because there's a potential translation issue here. Okay. So if we call, I guess, that P and that D, then you know that P of X over D of X is some other polynomial that we'll call Q plus some remainder R. That's not exactly how you said it though, is it? So it's equal to D of X, Q of X, plus R of X. So in this scenario, it's like we're undoing the division where we know if we divide P by D, we could undo that by taking D times some factor Q and adding back in the remainder R, which is where we get this equation from. And then we know that D is equal to 0 when X equals 0, I, or negative I. And we know that R is just, is it going to be a degree 2 polynomial? Are we going to have 3 equations, 3 unknowns? Oh, okay, and we do have 3 equations and 3 unknowns, underscore just cut to the chase. So we know that if we divide these two, the remainder should be some kind of quadratic, because there's a cube on the bottom. Wow, I wouldn't have guessed this as a way to solve this. And Q doesn't matter, or yeah, Q doesn't matter at all because it's going to get multiplied by 0. So we don't even care what Q is. So if we let X equals 0, we have P of 0 equals D of 0, Q of 0 plus R of 0. P of 0 is what we get when we plug 0 in on top, which is just -1. D of 0 is just 0. Q of 0, we don't even care about because it's multiplied by 0. And then R of 0 is C. So we get -1 equals C. And I should say basically the goal with this approach is to solve for R of X. That's the remainder. And that's how we're interpreting your question, Bio, that we want the remainder after this division. Okay, I guess that makes sense. So now we know what C is, and we need to use the other two roots that we found and plug those in too, because those have the same nice property with becoming 0 here. It's an interesting problem. I'm glad that I have people here to help me figure it out, because I wouldn't have gotten this on my own. Okay, so plug in I to the numerator. I said I to the 2023 is -I. And I hope that's right. That's 0 times Q of I. And R of I is going to be -A plus IB, and C is -1. Okay? And then we take X equals -I, and then we'll get a second equation to solve with. Let me Clean this up first, though. Okay. This marker is dying on me. You don't even need the minus I? Really? I don't see how you get A and B from just the one, but I'll do it this way, because that's the way that I can figure out at least. Okay, so if we plug in minus I, if that was minus I, or sorry, wait. Did I seriously say that P of I is just minus I and nothing else? My brain isn't working. Okay, I plugged in I to that first one and none of the other terms. So minus I is from I to the 2023. I to the 2021, well, 2020 is the closest multiple of 4, so if we go one after multiple of 4, it's like squaring it. And so I squared is -1, minus -1 is +1. And -2. Plus 5i minus 1. And I'm just going to skip writing r of I. Minus a plus ib minus 1. Okay, that looks more reasonable. Add the one over here. You solved it? Okay. What's your question, Bio? I'm gonna keep like working through it, but just to see it for myself, I guess. Minus I. That should be positive I. For the first one, I need to check my exponents. Gives you the right solution. Oh, I get why you don't even need the negative I case now. If you were to take negative I, you get a different solution? Huh. So I to the 23, that is negative I, so I did that much right at least. Is I to the 2021? Did I do that right? No, it's just I, and I said it was -1 for some reason. It's like there's 2 roots and not 3. I guess let me try working out, I guess I will continue on with my work and see if I have the same result as you. because we shouldn't get two different answers, I don't think. So the minus I is right. That should be positive I. There's still a minus sign in front of it. So -3 plus 1, I get 2, or -2. Plus 3i. But you're saying the correct answer is... Oh wait, you get -2 as well. Well, it's -a, so a is +2, I guess. Okay, so this would imply that a equals 2, b equals 3 in theory, but then if we try with -i, let's see how that changes. It should be just the signs flipped on those. For -i, the negative sign goes away for -i squared. So it's still just -1. So still -2, -5i, -1 equals -a plus ib -1. What happens here? I still get -2 minus 3i bio. Sorry. Oh, ooh, wait, -3i. That's not good. Because this is different. It's still -a, but that's -b. Minus ib. So now it's okay. So yeah, my match, bio. Minus I minus 2 plus 5i minus 1. What do I have? It's minus a plus bi minus 1. Yeah, so that matches for that line there. So we agree for x equals I. And I'm saying it looks a little bit different, but you should get the same solutions for x equals -i. So I think maybe you made an error somewhere. Minus 3i is for negative. So when you let x equals -i, you do get minus 3i, but it's also minus ib. That's like the difference there. So the sign looks different, but your r of negative I is different than r of I, basically. I'm gonna get some water while I wait to see if you say anything else. Okay. So yeah, I think this works. I guess I should hand out some saves here. Let me do that. So Yanis helped. Stooky helped. And underscore helped. Hey, Lofty. What's the R actually? Oh yeah, we can say that bio. So, oh shit. Sorry, I almost pulled my headphone cord out because it got stuck on my leg. Okay. Two solutions? There shouldn't be. You wait, so bio, we need to make sure we're on the same page. You do get the same A and B from plus I and minus I. You don't get different answers. If you're getting different answers, then you did something wrong. But from both of these, we can see that A equals 2 and B equals 3. So the actual answer is that the remainder of that division is 2x squared plus 3x minus 1. That's the answer, because A is 2, B is 3, C is negative 1. No, you only get one. No, you don't get different solutions. If you're getting different things for I and negative I, you did something wrong, bio. In both of these, A equals 2 and B equals 3. You shouldn't get two different things. It doesn't make sense for there to be two different remainders. I think that would break division. I mean, I don't know how it works for like complex numbers, I guess, but I feel like that'd be pretty bad. Equal division has one and only one remainder. Yeah. So yeah, like, if you... With x equals I, you get minus 3 plus 3i equals minus a plus ib minus 1. And for x equals negative I, you get minus 3 minus 3i equals minus a minus ib minus 1. These turn out, these can be the same exact a's and b's, bio. Because both of those signs are flipped. That's the important piece. That's why they come out to be the same. Yeah, that's what Yanis is saying too. So yeah, I mean, if you still got the wrong thing for the minus I case. Did they not provide the solution for this? That's kind of mean. Okay, awesome. Thanks for the question, Bio. And a bigger thanks to the people in chat who are helping me, because I'm not on it today. Oh, excuse me. Should we try the square root one? Like, they don't give us a solution, which kind of scares me. It feels kind of mean on the part of the book, but that quadratic one, I'm still kind of iffy with. And I just want to move on from the quadratic one, at least for now. So maybe let's try exploring this square root x one. See if we can figure it out. Hopes aren't that high, but let's at least give it a try. Oh, Ben, you're still up? Jeez, dude, yeah, good night. Get some sleep. Thanks for hanging out. Ah, get rid of that. Mark, it's going to annoy me. Okay. Okay. Bit too late, but time to sleep. I get it. All right, so epsilon delta limit as x goes to 9 of, 9, not a. I'm done with a's. A is weird. I hate a. Equals 3. Okay. Start up the way we always start it. For all, oh my god, let's say for x. For all epsilon greater than 0, there exists a delta greater than 0 such that the absolute value of x minus 9 is less than delta implies absolute value of root x minus 3 is less than epsilon. Okay. So let's do the normal scratch work, see what happens. So, you know, here we don't get a nice factoring thing, do we? So yeah, what would we do with the root x? I'd be tempted to multiply it by root x plus 3. Like, would we maybe say it's equal to, if we'd say it's the result of some division, we do this multiplication first, right? So we'd say it's equal to x minus 9 over root x plus 3. I don't know if this is a good idea or not. But I feel like we always have something to work with here. Oh, wait. Oh, okay. Yeah, this is probably what we want to do. Okay. That's something to work with there. So this is where things get a little tricky though, right? Because if we want to say so value of x minus 9 is less than 1, what about root x plus 3? What happens to that? Maybe let's start with minus 1 is less than x minus 9 minus 1. Can we manipulate this to get to root x plus 3? Well, square rooting each side of this is a little... I don't know if I like the idea of that. Well, we can add 12 to each side first. But square rooting each side like this isn't helpful. So we want just the x to have the root. So let's subtract the, I mean, okay, so let's isolate x and let's isolate x. Less than x is less than 10. Now we can square root things. Square rooting preserves inequalities. And I guess we just add 3. Ah. So if we know that the absolute value of x minus 9 is less than 1, we could also say the absolute value of root x plus 3, I think we want to bound it from above, because we're multiplying by epsilon, is less than root 10 plus 3. And so we could say that delta is less than epsilon times root 10 plus 3. Oops. I mean, the absolute value doesn't hurt, but it doesn't help. Kind of weird. Like, we have a constant choice of well, not constant. Never mind. A equals 3, it's not so bad. The general case is annoying. Yeah. Yes, I don't even want to try the general case, I don't think. Because it gets really weird. So that means we're gonna, let me not write delta there. I don't like having delta there. So that means we're gonna take delta equals to min 1 comma epsilon times root 10 plus 3, funny enough. Really? I guess so, yeah. Okay. So now let's do the actual, I guess, proof part. So here we start with x minus 9 is less than delta. And then our choice of delta is epsilon times root 10 plus 3. And so if we were to do these steps backwards, I'm going to kind of hand wave it, but we can say that root 10 plus 3, oh no. Did I bound it the wrong way again? No, how am I having the same? I have some kind of fundamental misunderstanding about epsilon, about the, or it's this process of doing epsilon delta proofs. Because here we want to bound it from above, and there we want to bound it from below. No, wait, do we? Yeah, no. Because now the bound from above is really bad. Because we can't compare x minus 9. That's why these could confuse me. Epsilon square root a plus 1 minus square root a, which is what I have. Oh, interesting. It's plus? Oh, you're saying the thing that you wrote there, Yanis? Okay. It's good to see that matches at least. This is for 2x equals 10, which is a nice case. I see some kind of parabola action happening. Oh, that's not an actual epsilon delta though. What is this over here? This is a separate problem. This one involves a quadratic. Hmm. Oh no, this is the geometric explanation. I made the same mistake twice in a row here, where my inequalities seem to go the wrong way. And it's really annoying me that I'm running into this issue. Because I feel like I'm just missing something simple. Yeah, sure, Yanis. So issues like in the scratch work, we want to bound it from above, but then when it comes time for the actual proof, it seems like we want to bound from below. And it should like be the same bound in both directions, shouldn't it? Like we should be able to use the same like bound that we just made. Yeah, so we can say that root x plus 3 is less than root 10 plus 3. But then that inequality goes the wrong way for the actual proof part. So I'm trying to look at like what we're doing at for other like epsilon delta proofs. Yeah, I just I get stuck on the actual mechanics of this proof. Like how I progress from the step that I have on the left in blue there. Oh, I guess I'll just look up a proof of this too. Continuity. I mean, I guess that works too. Find the max of 1 over that? I mean, if we have the min, I'm not sure where you're going with that, Richard, I guess. Um, oh, well, they just cut out the hard part, don't they? Like, what I'm interested in is what you do after the step, and they just say we're done. Okay, critical thinking. Solve the integral, assume from 0 to 1 of secant squared x over x root x using comparison. So you're not actually evaluating that integral, you're just saying whether it converges or diverges. Oh, well, so I haven't had to do this with an integral before, but it's just like with series. You can even function that's greater than it to see if it converges, or any function that's less than it and diverges to show divergence. That's weird. Yeah, and it's fair enough. I'm okay with just like I don't know. I guess I need to read this another time or just do some more research. So let's see what this function looks like critical thinking. So actually, well, okay. Can you tell me if I'm interpreting your text correctly here? Is this the integral from 0 to 1 of secant x squared over x square root x? So you're saying, yes, I do have those bounds correct there? I wonder what math actually does with it. Oh, well, spoiler alert, it diverges. But we need to actually show that, of course. So I still want to see the function like looks like. Oh yeah, of course it wouldn't be defined for negative x. Huh. It's kind of interesting. I guess it's adjusting the amplitude of secant. Okay. So yeah, we're doing this from the integral here from 0 to 1. So we want to name an integral that's easier to evaluate that we do know convergence and divergence for. So my guess is that we're going to take secant squared. We need to oh no. Hey, Ain't Begula one? How's it going? Skip was done previously. Oh. Alright, I'm just I'll maybe we'll try to look at it more later, but I'm doing good too. Thanks for asking. To run this problem from critical thinking. Secant doesn't blow up a 0. Make the other guess. Okay, that's fair, Stooky. Yeah, I assume that secant would blow up a 0. So, the question from critical thinking is, does this integral converge or diverge using the integral comparison test? Which was actually new for me. I've only done this with series, but it's basically the same concept. Wolfram Alpha has a spoiler alert that it diverges, and we want to actually show that. So we know that secant squared is always greater than or equal to 1. So we can say that 1 over x root x is less than this. Okay, good. So let me go to the whiteboard. You're only learning pre-calc right now? Oh, Yeah, so it's gonna be hard for you to understand ain't big EULA, but I'm happy to. If you have a question, please let me know. I'm happy to help with things that aren't like super hard calculus ones. And if you're just here to hang out, that's cool too. Okay. So the integral from 0 to 1, secant squared x over x root x dx. So even without the benefit of a graphing tool, we can make the statement that secant squared x is always greater than or equal to 1. If we suspect that it diverges, at least we're interested in things that are less than this function. And so if we know that 1 is less than or equal to secant squared, we could say that this integral is greater than or equal to 1 over x root x dx. And now the task would be to show that this integral diverges, which implies that that integral must diverge. The comparison is kind of weird because it's open-ended and you can choose, potentially many different functions, but you basically want to try modifying what you're given in some way that makes it easier. So I initially tried to make it secant squared x because I know secant squared, that's tangent, I think, if you integrate it. But this is what we actually want because secant doesn't behave quite right. It's hard to it doesn't give the behavior that we want for this problem. So if we're going to evaluate this integral here, we can use some exponent rules to say that x times root x is the same as x to the 3 over 2 dx. And then we can also bring the x up top if we make the exponent negative. 0 to 1 x to the minus 3 over 2. This isn't technically necessary if you are good with your exponents, but this is in a form where it's a bit easier to use the power rule now for integrating. So we're going to add 1 to the exponent, which will give us x to the minus 1/2, and then we divide by that new exponent, so we end up multiplying by -2. And we're writing from 0 to 1. Technically, this is an improper integral. I probably should have been... I think we need to have some limits out front here. I'm always lazy with these, and I don't write the limit until the very end. So we can also write -2 over root x, just to make it in a bit more of a familiar form here. Oh no, the adds! No! Shoot, underscore, I should have checked chat sooner. Really? You only just got ads? That's super weird. It should only be like the pre-rolls. And it seems like you were able to watch the stream for a little bit before the pre-rolls happened. Alright. Yeah, you missed the most important part. So wait, okay. I'm about to go back to the computer, but let's, okay, so if I'm gonna back up to the very beginning here, how should I explain this? So our interval is 0 to 1. The x over root x on the bottom has a problem with 0, because that means we're dividing by 0 here. Secant doesn't have a problem between 0 and 1. Secant, it only has asymptotes at like multiples of pi. So like negative pi, pi, 2 pi, 3 pi. I believe so. Secant is fine over this interval. With 0 and 1, it works just fine. Wait, is secant of 0 is really? Because secant is like cosine, yeah. So how should I explain this? Let me actually check chat in case something else went wrong. Divided by 0 limit thing, it is a limit thing. So, and the problem with taking supposed to have some limits, it's just kind of a pain to write it every time. But this function is going to blow up when x is close to 0, because when you divide by 0, the function blows up to infinity or negative infinity, but things are positive here. So this kind of x over root x is the problematic part that we want to kind of look at more. And we're going to suspect, I did cheat, but let's suspect that this diverges. And if we want to show that this integral diverges, we want to name an integral that is less than it that also diverges. So we know that secant squared is always greater than or equal to 1, just because of the way that the graph of secant looks, which we can look at if you're not sure. So we can say that this original integral is greater than or equal to 1 over x root x, because secant squared is always greater than or equal to 1. I hope we're good so far. I see an okay. I don't know what the whole part that was too, but I'm going to assume that you're okay with me so far. And the task from here would be showing that this integral diverges, or at least we'd integrate this and hope that it diverges, which would be the answer to the problem. So all I did here was I started to like rewrite x root x using exponent rules. So x root x is the same as x to the 3 over 2. And 1 over x to the 3 over 2 is the same as x to the negative 3 over 2. Then integrating that using the power rule, you add 1 to the exponent and divide by the new exponent. So you get negative 2 times x to the negative 1/2. And I rewrote the x to the negative 1/2 as over root x just to make it look a little bit easier. Oh, what's that? Oh, ain't beluga, or ain't Bagula. I'm going to call you beluga, I'm sorry. Or I'm going to accidentally call you that a lot because it looks like beluga. Either way, thank you for the follow. Okay, so 1 is fine with this, but 0 is going to be an issue. So we'll say negative 2 over root 1 minus limit as x goes to 0 from the right of negative 2 over root x. And so technically we should have had a limit like this like all throughout the problem, but it's a huge pain to write. So I didn't. And, shoot. But if you're on board with me for this part, I'm just gonna leave it. It's not necessarily the best form, the way that I wrote it exactly. So we're not quite there yet. Well, I mean, we basically are there. But yeah, so minus 2 over root 1 is just minus 2. And then this limit as x goes to 0 from the right is positive infinity. So minus 2 minus infinity. As soon as you see infinity as like a result in an integral, the thing diverges. So now we know this integral diverges, which implies that original integral that we were given also diverges. Okay. So if that makes sense, critical thinking. Awesome. No problem. Okay, and so ain't Bagula, do you have a question too, did you say? Oh god, I would love a simple question after the ones I've been trying today. I love a simple question in general, to be honest. Best types. Oh, you know what? I did have a thought. Like, I'm just kind of curious. What does the graph of secant to the x look like? Oh, it doesn't work? Why are you complaining? Oh, only secant squared and inverse secant. Okay. Oh, wait. Well, I can put the x on the outside, right? Oh. That's kind of boring. What? What? Oh my god. What? Oh, wait. Secant of a is just a constant. Okay, never mind. That wasn't... I was thinking like more like a multivariable function, I guess, but... Anyway, let's stop playing around with things. In sine and cosine functions, when, for example, c is 1/2, the first point 0 and period point pi is the first... What do you mean when c is 1/2? Like when cosine, if you have like cosine of x equals a half? So when I have a teacher, that's fair. First point 0. In sine and cosine function formula? Oh, you mean, are you talking about like a right triangle where like c is the hypotenuse? Or there's a couple of different formulas with cosine and sine, I guess. So I'm not sure which one exactly you're talking about. Oh, that one. Okay. So yeah, C is the phase shift. Actually, it's something written in a different way that it's a little bit... Oh, I mean, there's a whole... No, so what you're saying is like the general like form of a sine function. I thought you were talking about like identities, like sine squared plus cosine squared is 1, and there's a whole bunch of trig identities I thought you might have been talking about, but you don't mean any of these. Isn't? I want to find it in a slightly different way because there's like there's a little like trick here. So basically that C is more or less the phase shift, which is a left and right shift. I'm sure they show this in Desmos too. But yeah, if your C is 1/2, that means you're shifting to the left by a half. Just give me the actual thing, please. Okay, you know what we can do? We can actually use Desmos for this. So if let's let everything else be 1, I guess. If we just have y equals sine of x plus 1/2. I was wondering why. Okay. The first point 0 and period point pi. Yeah, so you basically like in this example here, sine normally is 0 at x equals pi. But if you're adding 1/2 and shifting everything, then I guess your first positive 0 is going to happen. I can't do math right now. Adding? You shift it to the left. Basically, the 0 that was right here is now to the left by 1/2. You always have to like. Dude, the rules with like function translations are always so weird to me. Okay, yeah, so I need to actually like see it like this. So yeah, we're shifting to the left when we do like a positive 1/2. Make C negative in all your practice? Okay. Yeah, if you want to add on that amount to your 0, then yeah, you don't want to have a negative there. Okay. God. I think I'm getting a little bit mathed out. I hate that I didn't get a bit more closure about this epsilon delta stuff, but I'm just gonna have to revisit it at another time, I think. Just make sure. Okay, there's something in the Discord. I see Talos is doing the keep talking nobody explodes stuff. There's someone else streaming the math category. I haven't seen this person before. Stylus Studios? Let me look at their stream. Huh. Okay. I think I'm not sure if this person is taking like questions, but we can go raid them and say hi. Because I think I want to wrap things up here for the day. So I'm going to cut off the YouTube stream here. So if you're here on YouTube, I appreciate you. I'll be back on YouTube on Tuesday. So goodbye, YouTube.